All right, history. Now, what's the time?
No, we got past.
Okay. All right, quadratic equations, talked a little bit about. Babylonians, I didn't write the Chinese because when I was typing this up last night, I couldn't find information to confirm what I thought I knew. But I'm pretty sure the Chinese, at the right moment in history, knew about completing the square. And as I love saying to my students, if the ancient Babylonians could complete the square, why can't you? Euclid, that was a surprise to me when I read it. I didn't know that Euclid was involved in quadratic equations, and I could be wrong, but it's interesting. Okay, how do you pronounce this? Brahmagupta, quite a well-known Indian mathematician. We're in AD now. He was the first to be quite rigorous about quadratic equations, all right? In the historical context, all of the ancients, they didn't have equations, they had problems, right? You know, you take this area of land and you do this and you do that and you end up with this result, and what did you start with, or something like that. And they didn't have algebra, they had processes that they described. I pity them. But even Brahmagupta, he did describe the solution in a somewhat algebraic way. It was just a paragraph of text instead of a formula. And he celebrated, or used negative numbers. It just didn't catch on in Europe until much later. This mathematician who I hadn't heard of, Abraham Bar Hanisi, Liber Embadorum, was published in Europe in 1145, which, really seriously dealt with the quadratic, kind of once and for all. Okay? Not in modern algebraic notation, of course, but yeah, I couldn't tell you what the difference between those two are. Maybe it's just a case of taking knowledge a while to spread. Maybe it's some refinement. Maybe it's a more thorough treatment of the different kinds of quadratic equations. Maybe it's talk of a discriminant. Who knows? You'd think the presenter would. All right, now we get to 16th century Italy, and this is amazing. All right, there's just the bang, 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 bang in the one century in the one place. Del Ferro. And by the way, who's heard of Cardano? Okay, so we've got less than half the room, right? Cardano's a giant of the story, but Del Ferro solved the depressed cubic. Now, we've seen both. Which one do you think was harder, the depressed cubic or the general cubic? The depressed cubic is the correct answer, all right? That was harder. Getting from the general cubic to the depressed cubic was not that hard. The substitution wasn't that hard. The simplification and all that was not that hard. It required the insight to make that one substitution, but the depressed cubic one, that involved all sorts of forks in the road and needing some genius, some inspiration. Now, I understand that he did it in a different way, but the way he did it looks equally impressive. Right? And once again, they didn't have algebraic notation. So they'd write, P dot for plus, M dot for minus, capital R with a subscript X for root, radix. And yeah, so Cardano's well known, and his slide is very long, but this guy should be well known. So Scipione del Ferro, he was a lecturer in arithmetic and geometry at the University of Bologna. I just find it amazing that there were universities, but there wasn't in Italy at the time. Yeah. So, it seems like the principal social organisation in this world isn't nation states, it's universities. So he solved the depressed cubic in 1515, and it's very interesting, if you're not already aware of this, which I wasn't until I read that book. Even though he was at university and a lecturer, there was not a culture of publishing your results and sharing your knowledge. Right? A bit different from nowadays. Certainly no publish or perish back then. He kept that to himself. And there's a very good reason he kept it to himself. The way you got ahead in those days was largely by competitions. At any time, someone with enough skill and enough cheek could challenge him effectively for his job. Right? So I challenge you to a public competition. I'm going to write 30 maths problems for you to solve. You write 30 for me to solve. See who wins. Right? There were audiences. Yeah. And so he kept that knowledge to himself so that he could defend any potential challenge. Now, I don't know any data on how many challenges he faced in his life, but that was the culture of the time, and that runs through our story. Okay, 2-bit players. Fiore was Del Ferro's student. Della Nave was Del Ferro's son-in-law. And when Del Ferro was dying in 1526, he passed on his knowledge of this cubic to these two gentlemen. They didn't broadcast it. They didn't need it as much as he did, although the student started to get ambition. Della Nave, son-in-law, I don't know if he had anything to do with mathematics, so he actually kept Del Ferro's notebooks, which is important for later in the story. So these guys kept his secret, but they weren't completely tight-lipped. You know, word got around that the depressed cubic had been solved, or at least that some progress in cubic equations had been made. Yes?
Given that sort of tradition, there's a possibility that other people did exactly the same,
yep.
And then it's just because they didn't pass it on, someone kept their books.
Yeah, I never thought about that. That's yeah. Although it never ceases to amaze me how much biographical information is known about these people, and so you'd hope to think that if other people did make that kind of progress, then it would be found out eventually.
Well, Newton kept a lot of stuff secret that only came out accidentally.
Yeah, that's right. And another player later in this story, some of his books were found in a university library in 1925. Yeah, I hadn't thought of that. That's a good point. So, it was kept secret. So yeah, Della Nave kept the books. Fiore just kept the knowledge. Okay, Tattaglia. Now, Mary, you mentioned Tattaglia yesterday and said, now what do we know about Tattaglia? And I shut you down pretty quickly as...
Didn't want to steal your thunder.
Now, I wasn't actually attempting to shut you down, but it got me wondering, well, I'm not going to say that many things about Tattaglia, so what were you going to say about him?
What was I going to say about it? Well, he was the guy, this story.
Good thing I shut you down then. So Tattaglia wasn't his name, Niccolo Fontana was his name, known as Tattaglia, called Stammerer.
And is that from a sword fight or something?
Rings a bell. We've probably read the same Wikipedia page. All right, his achievements were he solved a cubic of this form, 1535. So 20 years. And I think, just like when the 4-minute mile was broken, then other people did it, right? The knowledge that something can be done inspires people to do it. And so I think the word getting around that progress was being made inspired people, both by knowing it could be done, and secondly, by needing to build up some resources for a competition, perhaps. Okay, so he solved this one. And then there's a wonderful story about how he came to solve this one. Right? Now this is a rediscovery, all right, because that's the same as Del Ferro. Fiore, the student, challenged Tattaglia, all right, to a competition. Tattaglia he had a good teaching position. I think it was in Venice. Fiore wanted it. Fiore had this secret. There was perhaps a sense that things were moving on the cubic front, and so Fiore thought, well, I've got this knowledge that won't be secret forever, I'd better use it. Challenged to a competition, Tattaglia. The night before the competition, Tattaglia rediscovered this. So Fiore had no competitive advantage whatsoever, and Fiore didn't have this one. and he got wiped clean in the competition. All right, so Tattaglia was supreme there. For all the reading I've done on this, I have not seen how that was solved. And probably the reason for that is it's not important to the story. We saw how the general one led to this one, right? We don't need a specific solution to that. But I'd be interested to see the method.